Automatic control of air conditioners, Part 3. Automatic control systems of air conditioners will be explained. In Part 3, outdoor air cooling control and outdoor air cooling control with CO2 control will be explained. First, outdoor air cooling control is explained. The purpose of the outdoor air cooling control is to reduce cooling load and save energy. To do so, outdoor air enthalpy is compared with room enthalpy. If the intake of outdoor air is judged to be effective for air conditioning, the quantity of the adopted outdoor air is increased. The system shown on this slide is an example of an air conditioner consisting of a fan and chilled water and hot water coils. The automatic control equipment includes the DDC controller, the supply air temperature sensor TE1, the room temperature sensor TE2, the room humidity sensor HE1, the outdoor air temperature sensor TE3, the outdoor air humidity sensor HE2, the chilled water coil control valve TCV1, and the hot water coil control valve TCV2. The flow rate of the water volume passing through the chilled water and hot water coils is PID controlled to keep the supply air temperature constant, so that the supply air temperature detected in the supply air sensor TE1 is maintained at the set value. Meanwhile, the system drives the outdoor air damper MD1 and the exhaust damper MD3 in the open direction when outdoor air cooling is effective. On the other hand, the system drives the return air damper MD2 in the closed direction. As a result, the quantity of outdoor intake increases. When the outdoor air conditioner is turned off, the outdoor air MD1 and the exhaust damper MD3 completely close, while the return air damper MD2 completely opens. The DDC operation flow is explained. On this slide, the section that performs temperature control with the chilled water coil and the hot water coil is omitted. Only the section involved in damper control based on the supply air temperature is shown. The system shown on this slide consists of 17 control modules, 5 AI modules, an SP module, a PID module, a minimum valve travel setting module for the outdoor air MD, motor damper, 2 input conversion SW, switch modules, a FUNC, function module, an outdoor air cooling determination operation module, a DI module, 3 INT, interlock modules, and 3 AO modules. The temperature signal transmitted from the temperature sensor TE1 is adjusted in the AI module based on the 0 point and range which are set in advance. The adjusted value is sent to the PID module as the present value, PV. The supply air temperature setting value is set in the SP module in advance. The set value is sent to the PID module as the SP value. The PID module calculates and compares the SP value and PV value, and sends the attained PID control output signal to the SW module. If the outdoor air cooling determination signal from the FUNC module indicates off, the SW module reduces the valve travel of the outdoor air damper and the exhaust damper to a minimum. The signal directing the return air damper to move in a backward direction is sent from the AO module. As a result, the volume of fresh air is minimized. If the outdoor air cooling determination signal from the FUNC module indicates off, the outdoor air damper and the exhaust damper move in a forward direction, according to the control output from the PID module. It operates in the reverse manner to the ventilation damper, the outdoor air damper and the exhaust damper to maintain the air balance. The return air damper moves in a backward direction. As a result, fresh air is taken in. The FUNC module determines if outdoor air cooling is effective or not, and sends a signal to the SW module based on 4 input signals, that is, the room temperature signal, the room humidity signal, the outdoor air temperature signal and the outdoor air humidity signal. When the air conditioner is turned off, the outdoor air damper and the exhaust damper completely close, while the return air damper fully opens. This is the end of the explanation of outdoor air temperature control. Now, outdoor air cooling control with CO2 control is explained. Outdoor air cooling is controlled. Meanwhile, if the CO2 level in the room or in the return air is lower than or equal to the set value, the volume of fresh air to be taken in is adjusted to a minimum. As a result, energy can be saved. The system shown on this slide is an example of an air conditioner consisting of a fan and chilled water and hot water coils. The automatic control system includes the following components: the DDC controller, the supply air temperature sensor TE1, the room temperature sensor TE2, the room humidity sensor HE1, the return air CO2 level sensor CO2-1, the outdoor air temperature sensor TE3, the outdoor air humidity sensor HE2, chilled water coil control valve TCV1, and hot water coil control valve TCV2. If the CO2 level increases, not only is the outdoor air cooling controlled, but also the volume of fresh air increases by driving the outdoor air damper MD1 and the exhaust damper MD3 in the open direction and the return air damper MD2 in the closed direction. When the outdoor air conditioner is turned off, the outdoor air MD1 and the exhaust damper MD3 completely close, while the return air damper MD2 completely opens. The DDC operation flow is explained. On this slide, the section that performs temperature control with the chilled water coil and the hot water coil is omitted. Only the section involved in damper control based on the supply air temperature and the CO2 is shown. 4 control modules, that is, the AI module, the SP module, the PID module and the HISCL high selector module are added for CO2 control. The HISCL module compares the PID control output signal calculated in the PID module for CO2 density control with the control output signal from the PID module for outdoor air cooling control at the time outdoor air cooling is in effect. The higher control output signal of the two is output to each damper. As a result, dampers are controlled. Explanation of other modules is omitted because they are those used in the outdoor air cooling control system. This is the end of the explanation of outdoor air cooling control with CO2 control. This is the end of the explanation of automatic control of air conditioners, Part 3.